This is a video for section 3.3. We're going to look at derivatives of trigonometric functions. Number one, the derivative of sine x with respect to x is cosine x. Number two, the derivative of cosine x with respect to x is negative sine x. Let's recall the quotient rule. The derivative of f of x over g of x with respect to x is equal to g of x times f prime of x minus f of x times g prime of x over g of x squared. So that's the quotient rule. We're going to need that on the next page. Let f of x equal tangent x, which I'm going to write tangent x as sine x over cosine x. We're going to take the derivative of f of x with respect to x, and we're going to use the quotient rule. So f prime of x is equal to the bottom function, which is cosine x, times the derivative of the top function with respect to x. And the derivative of sine x with respect to x is cosine x, minus sine x, that's the top function, and we're going to multiply sine x by the derivative of the bottom function with respect to x. So in other words, we're going to take the derivative of cosine x with respect to x, which is negative sine x, and we're going to take that result and then divide by cosine squared x. And so f prime of x is cosine squared x plus sine squared x divided by cosine squared x. But remember that cosine squared x plus sine squared x is equal to 1. And so f prime of x is 1 over cosine squared x, which is equal to secant squared x. So f prime of x is secant squared x, and that leads us to rule number 3. Rule number 3 says the derivative of tangent x with respect to x is equal to secant squared x. Now, let f of x equal cosecant x, which is equal to 1 over sine x. And we're going to do the quotient rule again. So f prime of x is equal to sine of x times the derivative of 1 with respect to x, which is equal to 0, minus 1 times the derivative of sine x with respect to x, which is cosine x, right? So the numerator should be sine x times 0 minus 1 times cosine x. And we're going to take that entire result and then divide by sine squared x. Now, I want you to notice how I write this. I write this very strategically. This is equal to negative 1 times cosine x divided by sine x times sine x. Remember that sine squared x is sine x times sine x. And I'm going to section it off accordingly. Now, I want you to notice that negative 1 divided by sine x is equal to negative cosecant x. And then cosine x divided by sine x is equal to cotangent x. And so f prime of x is equal to negative cosecant x cotangent x. And that's going to lead us to rule number 4. And that says the derivative of cosecant x with respect to x is equal to negative cosecant x cotangent x. Now let g of x equal secant x, which is equal to 1 over cosine x. And I basically do the same thing. G prime of x is cosine of x times 0 minus 1 times negative sine x divided by cosine squared x. So I'm just applying the quotient rule on 1 over cosine x. But that's 1 times sine x divided by cosine x times cosine x. Remember that cosine squared x is cosine x times cosine x. Now, if I section this off accordingly, notice that 1 over cosine x is equal to secant x, and sine of x divided by cosine of x is equal to tangent x. So g prime of x is secant x times tangent x. And that leads us to rule 5. Rule 5 says the derivative of secant x with respect to x is secant x times tangent x. Now let h of x equal cotangent of x, which is equal to cosine x over sine x. So I'm going to apply the quotient rule again. So notice how I applied the quotient rule on the last four rules. Now, h prime of x is sine of x times negative sine x. Remember that the derivative of cosine x with respect to x is negative sine x. So I get h prime of x again is sine x times negative sine x minus cosine x, that's the top function, times the derivative of sine x with respect to x, which is cosine x. And I'm going to take that result and divide by sine squared x. I factored out a negative and got the opposite of sine squared x plus cosine squared x divided by sine squared x. And so that says h prime of x, which is equal to negative 1 over sine squared x. And that's equal to negative cosecant squared x. And that leads us to rule number 6. Rule number 6 says the derivative of cotangent x with respect to x is negative cosecant squared x. And I would encourage you guys to write these derivative rules on flashcards to help you remember. Now, let's take a look at some examples. The directions basically say to differentiate. And let's take a look at number 1. Suppose f of x is equal to 3 sine x minus 2 cosine x. And I want to find f prime of x. And you need to label this f prime of x. That's very important. Now, 3 is constant, so that's going to go along for the ride. And the derivative of sine x with respect to x is equal to cosine x. So this is 3 times cosine x. And then I'm going to subtract 2, and then I'm going to take the derivative of cosine x with respect to x, and that's going to produce negative sine x. But remember, a negative times a negative is a positive. And so, therefore, f prime of x is equal to 3 cosine x plus 2 sine x. And in a nutshell, that's how you do problem number 1. Let's take a look at problem number 3. Suppose y equals x squared plus cotangent x, and I want y prime. The derivative of x squared with respect to x is equal to 2x. And the derivative of cotangent x with respect to x is equal to negative cosecant squared x. And that's just going to take getting used to. There's no way around that. And again, I would encourage you to use flashcards to help you remember these different formulas. And so, again, the derivative of cotangent x with respect to x is negative cosecant squared x. And so if I go to simplify this, y prime is 2x minus cosecant squared x. And that's how we do problem number 3. If we take a look at problem 5, if I have h of theta is equal to theta squared sine theta, that's a product of two functions. With a product of two functions, we need to apply the product rule. And remember, you're taking the derivative in context. You're taking the derivative with respect to theta this time. So I'm going to write down the first function, which is theta squared. And I'm going to take the derivative of the second function. So in other words, I'm going to take the derivative of sine theta with respect to theta, which is equal to cosine theta. And then I'm going to write down sine theta. And then I'm going to take the derivative of theta squared with respect to theta, which is equal to 2 theta. And so I'm going to factor out a theta from both terms. And when I do, I get theta cosine theta plus 2 sine theta in parentheses. And so again, therefore, h prime of theta is equal to theta times the quantity, theta cosine theta plus 2 sine theta. That's number 5. If we take a look at problem 7, suppose y equals secant theta, tangent theta, and I want y prime. So I'm going to write down the first function, which is secant theta. I'm going to take the derivative of tangent theta with respect to theta, which is secant squared theta. And then I'm going to add tangent theta and then multiply by the derivative of the first function with respect to theta, which is equal to secant theta tangent theta. So if I go to simplify this a bit, I get secant cubed theta plus secant theta times tangent squared theta. Now, I can go ahead and factor out a secant theta. And when I do, I get secant squared theta plus tangent squared theta in parentheses. Now, be careful because secant squared theta plus tangent squared theta is not equal to 1. So it's about all we can do with that. On number 9, suppose f of theta is equal to theta minus cosine theta times sine theta. And I want f prime of theta. So I'm going to write down the first function, which is theta minus cosine theta. And I'm going to take the derivative of the second function. So the derivative of sine theta with respect to theta is cosine theta. And then I'm going to add sine theta. So you guys notice this is classic product rule. And then I'm going to take the derivative of theta minus cosine theta with respect to theta. The derivative of theta with respect to theta is 1. The derivative of cosine theta with respect to theta is negative sine theta. So I'll write this in red. So we get 1 minus negative sine theta. Okay. So this is theta cosine theta minus cosine squared theta plus sine theta plus sine squared theta. And so f prime of theta is theta cosine theta plus sine theta. And I'm going to do something to you guys here. Now, I'm going to factor out a negative and write these remaining two terms as cosine squared theta minus sine squared theta. But remember that, let's go back. Remember that cosine squared theta minus sine squared theta is cosine 2 theta. And so this is theta cosine theta plus sine theta minus cosine 2 theta. And again, that's equal to f prime of theta. That's number 9. If we take a look at problem number 11, suppose h of t is cosine squared t, but that's equal to cosine t times cosine t, okay? And this is a classic product rule problem. So h prime of t, we're going to write down the first function, which is cosine t. We're going to take the derivative of the second function, which is negative sine t. So again, the derivative of cosine t with respect to t is negative sine t. And then I'm going to write down the second function and take the derivative of the first function, which again is negative sine t. And so h prime of t is negative 2 cosine t sine t. And that should look familiar. So it turns out h prime of t is negative sine 2t. That's number 11. Let's take a look at 13. Suppose f of theta is sine theta divided by 1 plus cosine theta. So this is a quotient rule problem. And so f prime of theta, we're going to write down the bottom function, which is 1 plus cosine theta. And we're going to take the derivative of the top function. The derivative of sine theta with respect to theta is cosine theta. And we're going to go minus sine theta. And then I'm going to take the derivative of the bottom function with respect to theta. And the derivative of 1 is 0. The derivative of cosine theta with respect to theta is negative sine theta. So, and I'm going to go ahead and divide this by 1 plus cosine theta squared. And so f prime of theta is cosine theta plus cosine squared theta plus sine squared theta divided by 1 plus cosine theta squared. But cosine squared theta plus sine squared theta is 1. And so f prime of theta is cosine theta plus 1 divided by 1 plus cosine theta squared. But we can simplify this a little bit further. And so f prime of theta is 1 over 1 plus cosine theta. And that's how you do problem 13. And let's take a look at 15 for a good stopping point. So on 15, we have the following. We have y equals x over 2 minus tangent x. Again, this is a classic quotient rule problem. So y prime, we're going to write down the bottom function, which is 2 minus tangent x. We're going to take the derivative of the top function. So the derivative of x with respect to x is 1. We're going to subtract x times the derivative of the bottom function, which is 0 minus secant squared x. So I'll just put in negative secant squared x, and I'm going to divide by 2 minus tangent x raised to the second power. And so y prime is, up on top, we get 2 minus tangent x plus x secant squared x. On the bottom, we get 2 minus tangent x to the second. And that's a good stopping point for y prime. That's going to conclude this video for section 3.3. We talked about the derivative rules of the 6 trigonometric functions and worked problems 1 through 15 odd. Okay, thank you.